introduction. I'm mentally ill, so I like it. Okay, I'm really happy to be here. This is wonderful. I love being in an experimental setting anyway. As long as I don't touch anything, I hope everything will But, okay, so I've shortened the title a little bit, Conscious Observer Discovers Event-Oriented Physics. So hopefully all of you will be such observers, and this is going to be kind of a follow-on to what I did 2 years ago, and bring you back up to speed. Okay, I showed this slide a couple of years ago. It puts you into the context of what I'm talking about. And the context is that there has always been a battle, if you will, between the concept of Aristotle, who said that we see reality pretty much as it is. Plato, on the other hand, said what we actually see are the shadows, or equivalent to shadows in a cave, right? Which means that what you see out here, what I see of you, and vice versa, in Plato's view, is an internal phenomena, and the reality is somewhere outside the cave. In modern technology, that would mean the you is inside your skull, and you are looking at something which is an interpretation of the stimulation that comes from the outside, an interpretation contrary to Aristotle's point of view, which is that we are seeing the reality directly. Now, Plato view was associated with religion for a long time. I use Thomas Aquinas here as the point at which the Catholic Church began to consider that maybe Aristotle was correct. From this point of view, we had the Renaissance, objective science was developed, and we more or less conquered the whole world, at least the Western world, with that philosophy of the fact that we were seeing the world directly, until Max Planck came along and until scientists began to look at what is inside of material, right? And Max Planck was the first one. I had his icon here. From that point of view, we developed quantum theory, also relativity, although there's a conflict, I understand that, and beyond. I then went back. This is something that happened to me when I was at Berkeley, my physics thesis there. Never quite understood how quantum mechanics was developed. I still don't know, and I don't think it was ever really logically developed but I've been working on that ever since.
Wait until my talk.
Pardon?
Wait for my talk.
Okay, well, we'll see. So I have gone back just basically to classical mechanics, what we know from there, added the idea that there is a quantum of action, and developed what I call cognitive action theory, which I've presented. And now going to the next slide. Today we are in, oops, wrong one. Okay, we're sort of here. What I see is that almost everyone, I call Vigier participants, the United Fields Theory, especially the talk I saw yesterday and so on, has the mentality that it is out there. Wrong. The out there never has been out there. It's you. It is inside yourself. This thing, this room, is a sensation inside yourself, and you must differentiate that from the concept that you develop of what the reality is that explains the sensation. Okay? And what I want to propose now, this is since 2 years, I've made some progress, and I believe that we can integrate these 2 points of view by considering that we move not to an object-oriented worldview, not to the fact that it's objects out there, but that is an event-oriented worldview, and that there is, in fact, that we are, you and I, are, in fact, an explanatory measurement cycle of activity, and that cycle of activity can be defined as an action cycle, which can be the basis of physics. And I want to propose that to you. Okay, so, oh, it's sensitive. I got to be real careful. I don't want to touch this stuff. Okay, so here is our actual situation, right? This is a drawing that I actually drew during my thesis work at Berkeley. It's from the left view of your eye. You close one eye, you see your nose here. You see this. And this is what you see inside of Plato's cave, right? So we're out here. The internal eye is looking at the world through one sensor system, right? Well, all we ever have had, and unless you want to go, I'd say crazy, but all we have is this first person view. Okay? We can't get out. But what we can do, and all we have to do, is build symbolic models. Which means that those prisoners inside Plato's cave, unlike Plato and unlike Tekmark, who wrote the book now about the ideal mathematical universe, what I believe that they should do in the cave is to write something on a book. And those books are our theories, and there is a transformation between what you see, what we write on the book, which in turn goes back to predicting what we should be seeing, and that's that cycle of activity that I believe is fundamental. The question here is the cat an object? For example, this is what you see, right? So there's a difference now between what you see and what you think it really is. What you see in the psychology and soft-headed world of art, we call that qualia, right? So the qualia is your color and all these other things. We project into it our explanation of it. But the question is, what is it? In quantum mechanics, is this an object, or is it a wave, or is it something else? So here we have some possibilities. Classical mechanics is built on this object concept that the world is like we see it. Quantum mechanics recognizes that there's something between what the reality is, which is a barrier. Kant called that thing outside the unknowable, and it probably is unknowable in a normal sense of the word, but what we do is to try to build some sort of a model that allows us to manipulate this unknowable. Okay. Okay, so my thesis, if you will, is that what we should be doing, the next step, is to look at an object-oriented to event-oriented shift through this process. First, there's classical physics, which describes very well the concept of the object world that we believe is external to ourselves. Then there's the quantum physics world, which recognizes in sort of a grudging way that the external world is not what we see. There's a barrier called the von Neumann cut, or Heisenberg cut, depending on who you read, that this might be the reality outside, which then runs through the Heisenberg cut, the detector cells that we use in order to produce the thing. And what I'm proposing is that we replace this now with a cycle of activity, which is a measurement explanatory activity. The material of activity is action. The form of activity is the state at which action moves, runs around where it's formed, right? And therefore, in this viewpoint, reality is a form of action. And I'll press this button. Yeah. A little more concretely, one now sees in what I've done in order to make this work one sees several expansions. And that is that what I've defined here is that material, which consists of the detector and effector cells that basically are built out of, and that is a transition, now has two sides. One is the interior of matter, is where the psychological mental display system is located, which produces the situations, the sensations that you see. The other side is the traditional classical mechanical side, that's the physical reality, and I use these icons, which I'll explain in a second. What's moving along here is that there's an action system, and so now material in this concept has four sides: the future, the past, and the inside and the outside. Traditionally, quantum mechanics is attempting to, in a very rudimentary way, actually explaining the physics of the inside of material. I am saying that's not yet a full theory. We have to move ahead and recognize that there is a complete inside and that the two are very directly connected, and that that connection is something that we can understand only symbolically in a kind of transcendental point of view, which is all we have when we are talking about symbols. So, what does that happen? What that does is it says, in the traditional world, we have always, in the traditional physics, we've always assumed that mass and charge are connected and are at the same point, are properties of a particle. Particle is something, it has properties of charge and it has properties of mass. I have doubled those two by saying that mass and charge should in fact be treated as two separate entities, and that there is a force, a general force, between the two, which I call the force between charge and mass, and the force between mass and charge. So I've added those two. And I've added that now to the extended, or what's now the extended D'Alembert principle, which becomes basically a force statement. And that now says, given these additional forces between charge and mass, we have the traditional, here's forces of electromagnetism, it deals with charge. Here's the forces of mass, it deals with the mass. They interact with each other through the external universe that we're all knowing. But inside of material, there is an additional set of forces, which I'm now just calling force of charge and mass, but it leaves you still with those four fundamental forces. Okay, so here's a list of them. Here is matter only exists where all of these forces are balanced. That's a very important concept. And we can also make an extended action principle, which says matter wants to feel more action flowing through itself. So I have two principles that I'm proposing that determine the behavior of material, which is very equivalent to the behavior of ourselves as human beings. So I'm combining all of these into one thing. Two principles. We all want to experience more action, and all material does. And we want to experience that in a form which is in equilibrium so that all the forces are balanced. So those are the two principles. They apply to you and me, and they apply to material as a whole. Here's the aspects of matter now. Okay, here's the cycle again. There's the blue squares are matter. These are round. They're separated very slightly. And here is the traditional gravitational and inertial forces and the electro and magnetic forces on the outside, and here is on the inside. This is our internal view. This is us seeing things. This is where our sensations are being presented. This on the outside is theory. No one has ever seen a charge. No one has ever seen a mass. What you see is quality, color, sensation, touch. it has always been a theoretical projection that its mass, or its charge, or its energy, or any of those things are a theoretical projection from what we actually feel. And through the course of the development of that theory, we go from gods being the explanation of what we see, to matter and classical physics, to quantum physics, and we're still moving in that direction. And I think this is the group that's doing most of the heavy lifting in the direction that I think the future is coming in. So what that means is the external view of material hides the subjective inside. This is the past. The past is always the radiating side outward, which now goes to another one. If it moves around, it comes back from what might be the future. In other words, what you see is always, everything, the chairs I see, your faces that I see, is always in the past. Because it's from them that radiation has come to the future, which then I interpret as your, so I'm always seeing something that's in the past. Now, let me get into some physics. So this might actually be a theorem. It turns out that there is a direct relationship, or two ways of looking at the same thing, really, which is that the force, what this says is, if there is two interacting degrees of freedom, I'm calling Q1 and Q2, then in those degrees of freedom, this axis is the momentum. So there's a certain amount of momentum here, there's a certain amount of momentum in the second axis. Now, you can see that the momentum is the same in both of these. The system, both of these combined, is this line here. So you can see that I'm adding the momentums together, so this is the total momentum in the system, and it's constant, because now I'm assuming these two are isolated. Okay? So now it's constant. There's a line here, which is an angle that's slightly more in this direction, because there's a little more momentum here than there is here. It's constant until it reaches this point where interaction starts. Interaction is such that there is a force. The force between these two is that this decreases the momentum, P, for a certain period of time. This here increases it, and it's accompanied by a movement of action from the decreasing to the increasing. And the equation here for the action in the second degree of freedom is this original momentum minus 1/2 the change in its momentum multiplied by the distance over here at which the interaction takes place. Okay, so these are two alternative ways of looking at the same thing. One is the Newtonian force picture that we basically build most of our physics on, even though quantum mechanics pretends to be something else. But in actuality, you can always do the physics as a motion of action going from one to another degree of freedom. If you combine those two with the four aspects of matter now, we get something like this here. So let me go through this. So assuming that we start somewhere at 1, there is a force that takes this charge, this is a degree of freedom here, and says, okay, I'm going to move from action this direction, which means that this is increasing and therefore decreasing its position. While that action is flowing through, it sends information to the next one, and therefore there is a reaction force in the electromagnetic field that pushes it back to its original position and pushes forward the next charge over here, which now, as it flows through, interacts with matter, meaning that there's a reaction force between, this is actually should be between mass and charge, so I'm sure this is these two are reversed here. It goes in this direction. So what that means is that the action flows around here if I assume that the action is a pulse. I'll take a quick question, but
It was just related to your previous slide.
yeah.
What happens if, is it possible for the, that interacting line coming out between the two axes, what happens if it goes completely to one axis or the other? Is that possible?
I'm not sure if I want to understand what axis, when this is just a simplification of how these masses and charges now are related to each other, because we have four aspects of them.
No, I just meant on the previous slide when you had that, you were talking about the immediately previous one, or that one.
Okay.
What happens if that the middle interaction line right there, is it possible?
This is the system line, the combination of the two.
What happens, is it possible to go completely, be biased to completely one axis or another, or is that impossible?
I mean, if there's only one axis altogether?
No. What I mean is if that interaction curve gets so biased towards that axis that it coincides with that axis, is that possible or no?
Yeah, I mean, if there's only one system and one degree of freedom altogether,
Okay.
then the system is only one, and they coincide. Yeah.
Okay.
But then there's no interaction.
Okay.
And have an interaction, it just keeps going forever and ever, and that, it's only when you have multiple degrees of freedom that there's an interaction. So what I'm saying here is that once you understand this formula, you recognize that a flow of action is equivalent, an alternative way of explaining, or an alternative physics to the old force relationships between degrees of freedom. The nice thing is that if I reformulate physics in terms of action flow, then I have a mechanism where action can flow from the outside to the inside of the material, and in the inside of the material it allows me to explain our personal sensations, what we see. And that has been completely outside of physics so far. The main criticism of this kind of approach is that it's not physics. My theory, my thesis, which I tried to work on that 50 years ago now at Berkeley, they said, wonderful theory, but it's not physics. And I was glad that Charles Towns was on my thesis committee, and we had a lot of discussions, and he said, look, I'm sorry, we can't give you a PhD on something that we don't consider physics. I started applying to be a lawyer, because I was kind of pissed about this sort of thing, because I thought this was the future. But we reached a compromise, and they said, okay,
You shouldn't have.
do a regular thesis, put all of this stuff, I said, I've got to put myself into I'm doing the experiment, I got to be in there, this is the future of physics, and they said, make that into your appendix. So some of these drawings actually are out in the appendix. So I've been working on this for a while. Okay, so down. All right, so here is the situation. When I draw the squares of material, of course, there is no boundary condition. Right?
Okay.
So the boundary condition of a square means that there's always some side, some boundary, right? So now you can close that. So from an aesthetic point of view, we are in fact something like a toroid, which is nice. I think there's a lot of coupling that needs to be done. If you take one instant on that toroid, you end up with those squares, so the boundary conditions are more in both directions. So time is closed, space is closed, and action flows in the time direction, right here. And here's the subjective person. And it also flows in the spatial direction. So there's a flow of action, mainly through time, but also interacting with space. And this brings me to the new, I would say, vision of reality, which is that each of us are, to first order, a self-contained explanatory measurement system that can be visualized by a flow of activity or action. Right? And we are interacting with all these other persons. So when everybody talks about a ether or an underlying something, I'm saying that is your underlying something. You are the ether. It happens in you. Interactions between them change your state, and the symptom of that change is the motion of the systems, motions of the objects, the bodies that you see around you moving. Those are the symptoms of interactions being interpreted. So now I'm going to go on to show you how some of the classical physical mechanics will actually support this concept. And that is that one thing is that in classic physics, we're always assuming that isolated events don't include their own clock. But now I'm suggesting that a truly isolated event must contain its own clock. In other words, it contains time or motion inside itself. What that means physically is here, if we have a measurement from Q1 to some degree of freedom here, that defines an external piece of equipment. I mean, we do this all the time. And I'm including now the clock as a Q0 degree of freedom. That leaves me with another column here, which includes both of them. And that column now is a kind of a time or a state function. I underline that with a W, so that the state function there is a composite. And I can make a function, which is essentially the time, as part of all the degrees of freedom, including a clock. I can then also calculate the action between one state and another as also being a function of the change that happens in all of these parameters. And I can define energy as energy now is the rate of change of action through a state interval. Okay, so now I have a state. And it allows me to define the same activity from two separate points of view. One is the energy time of the entire system, and the other is the position of momentum of all of these states of degree, which now can be a function of these two big functions, plus a whole bunch of constant parameters.
So you're saying you have two action phases, a time, energy, and momentum.
I have two ways of looking at a normal system.
So it's the same phase?
It's the same system.
Good. Right.
Right. It's the same, but I'm including the clock.
Good.
Right?
Right.
So I'm doing that.
Good.
Okay, now, what does that, should we go through this? Okay, so what that means is, since I'm looking at the same system, the change in action, whether it's calculated in an energy time or energy state point of view, or if I look at all of the momentum and position changes point of view, this thing is two ways of looking at the same thing. I subtract these two from each other and I get 0, which means that this thing, which includes the clock now, minus the energy time point of view, gets 0. I split out the clock here, clock, now I'm calling P0 PT, just to make sure that you understand that's the clock phase. Subtract that two, multiply them through, identify the force and velocities, because QF divided by T will P, the change in P in momentum divided by time is the force. The change in position divided by time is a velocity. This is basically relativistic, so I subtract that from the clock. I convert that to normal momentum and kinetic energy potentials, and I come up with an equation that looks like this for the energy. This is basically a Lagrangian. Divide through by time, and I get the standard phone's characteristic function, or what is normally called just the action function. And so what we've got here is that this is something quite interesting. In classic physics, we assume that the entire system, everything we see, is driven by some external God-given clock, right? I've identified that as the system time as defined earlier, right? Okay, so in other words, what I've said is this external God-given is another way of looking at an entire system that includes the clock and includes the time, because that's the way it can become self-sufficient. And when I do that, then I come up with the fact that in an isolated system, the action has to be zero because I'm just looking at it from two different points of view. When I change and I use a measured clock, in other words, and then I get a slightly different velocity and a slightly different momentum, which we call a normal velocity and normal momentum, and I get this function, which is the standard view. But what it does is tell you that this action function has always been the relationship or the interaction between any system and the clock. The difference now is that the system time, which includes the clock, is different from the measured time, Vt, which we always do when we do an engineering or any kind of calculation. And the origin of the special relativistic correction is simply a correction to changing from a God-given external time to a measured time. In other words, what Einstein did is to say, realistically, we are always going to do experiments based on a measured clock. The measured clock has always been the universe. And in my terminology now, if I divide the total, the whole, the universe, into an eye of the observer and the rest of the universe is the clock, rotating Earth and all the masses moving and so on and so forth, then what I find is an isolated eye is simply two ways, internal and external way of looking at the same action rotation. Right? So this gives me my PFs and QFs, so details. This is the energy flowing through the first person. This is sort of a third person point of view, so this is an internal one. And the external one from the outside is the additional thing that you add to your internal energy, because the first person perceives both his internal flow of action as well as the action that comes in from the outside. That difference now is what is minimized, and what that means is that we can explain, if you will, that in Kant the minimum action principle is recognized simply as a desire for all cognitive action loops to increase the amount of action they experience. Okay?
I'm probably being stupid here, but you can tell me that in a minute. But I mean, normally the action principle is for a stationary point of the action, so minimum or maximum. Is that really the wrong way around? Isn't the minimum maximum cognitive action loops to decrease the amount of action they experience to experience a minimum? But which would also be stationary, of course, so still satisfy the action principle. Do you mean maximum or minimum there?
Well,
Still stationary.
this is a sign question here.
Yeah, obviously.
So, I mean, you could switch things around, but you know,
I try and minimize action usually myself.
well, I mean, the original minimum action principle is
Okay, stupid question.
You're trying to minimize.
Stationary.
Essentially, what's going on here is that you are looking in one direction of time. That direction is a combination of your internal and your external point of view. If you have those 2 points of view, you're looking at one, and what you're trying to do is maximize during an interaction, trying to maximize what appears to be.
You say that minimum action universe equals maximum action U.
Yeah.
Okay, right, good.
Okay, so now let's apply this idea to one more concept here, and this comes from Penrose, who tried to explain, and this is called gravitational collapse of the wave function here. So an explanation for that. So we know the Mach-Zehnder interferometer. We know that if we leave it alone, there's a split here. Photon comes in. Although I really don't like photons myself. I think they're an illusion. But they split, hit some reflected mirrors, and if you do not know which direction the photon where it reflected, then you get output on one or the other of those detectors. If you happen to know which one it bounced off of, so now the photon goes through, it went in this direction because you measured it, then the photon must be here, it goes through this wave splitter, and what you end up with is a result in both of these. So in other words, you get two different results out of this experiment, depending on whether you have measured or know which way the photon goes. Typical quantum mechanical problem. Now Penrose said, okay, in order to make that measurement, some detector thing has to move. So these are the two masses that it moves, and Penrose calculates the displacement or relaxation time. He said, well, if there's a mass and it can move from one state to another, which would indicate that the photon has gone through, then it takes a certain amount of time to calculate that relaxation time as being the relaxation time and actually being the cause of the collapse of the wave function.
10 minutes.
Here's my last slide. So in my system, what happens is that the photon goes through, hits here, right? It doesn't hit both at the same time. The photon is an electromagnetic force. Therefore, it splits from an equilibrium state, it splits the charge from the mass, moves in this direction by purely electromagnetic force. Now, the mass portion of, these are tiny little things in here, the mass portion of it feels a force because it wants to be close to the equilibrium with the charge, which means that the mass needs to send out into the world the fact that it is now changing its original equilibrium from where it was to where it wants to be, right? And in order to do that, it needs to go out to the rest of the universe and establish an equilibrium. It may or may not. If it does, the situation doesn't happen. The mass and charge now have moved to a new equilibrium. You've made the measurement, and you've seen the result. Right? And what's happened here, in my view, is that the charge has moved, pulls the mass along. The mass needs to establish its equilibrium with the rest of the universe in order to make the movement. So in order for this to happen, in order for that measurement to happen, there has to be an equality of balance or equilibrium, both in the total charge field and the total mass field of the universe. And if that doesn't happen, then you don't make that measurement, and you don't know whether it's gone through, and then you get one state result of the experiment, and if it does happen, you get a collapse, if you will. So now I've explained the collapse of the wave function. Now I'm done with my basic talk. I can take some questions, or I have gobs of additional things to talk about, because this is a whole new way of looking at things, because basically what I'm saying is, let's stop, and I want your help on all this, let's stop talking about what's going on out there. Let's talk about how we build ourselves in order to interpret what is going on out there. Let's talk about building the physics of ourselves, of our own system, and that's what Heisenberg actually talked about. You know, Heisenberg said that quantum mechanics is not the physics of the world out there, it's the physics of the observer who is observing the world. So, okay, questions? Now,
Some of us think that we're trying to develop a physics theory, or physics theories, that explain phenomena that occurred eons ago before there was any observer anywhere.
right,
Now, in those terms, you wouldn't want to think about what's going on inside anybody's heads because there are no heads yet.
right.
So the laws you're trying to find would be utterly independent of what goes on or what is destined to go on much later in heads that have, at that point, still not even come into existence.
Right.
So I'm a little bit at a loss to see where this is going to give us. We also think,
Well,
I see, most of us think that the principles of quantum mechanics, whatever they are, however well they are explained or unexplained at the moment, still obtained before there were heads to worry about.
right.
Yeah.
That approach and that thought and that frame of mind is based on the assumption that the world out there existed independently and before you. I'm saying that, and Plato, that is not the case. What has always happened is that all physicists have taken the phenomena that they experience and explain them and project their explanations back into the phenomena, and now they believe more in their explanations. When I'm looking at you and I'm normally walking around, I think that there's a mass out there, and photons are bouncing off those surfaces. There's charges that are reflecting. I'll take some other questions before, but I haven't answered that. But let me give you an idea. Go out at night, lie down. I do this sometimes.
Look at the stars.
And look at the stars.
Okay.
So now, you look at the stars, and there's absolutely no question. You're seeing stars out there, right? Well, no. What you're seeing out there is a local phenomenon in your retina, right? Correct. The light that you see is the projection of the explanation of the interaction on your retina by your brain into that sky. And so is every experimental result on every photographic plate. The phenomena happen there. And it's the explanation and projection, the mental activity, that tells us, oh, it must have been something out there.
I think you're on the, for me, you're on the right lines a lot of the way, and it goes back to the interaction with the observer theory, the Feynman Wheeler stuff that Carpenter talked about a couple of years ago as well. We had this discussion about whether or not you need to have the observer, the absorber, the observer, be part of the process, even over eons, multiple eons, 2 points well taken. But if that is the case, then what Wolf's saying holds a lot of water. It's what's happening here and now. And the space and time in which we measure things is our ruler and our clock here and now in this room. What the ruler and clock was eons ago may have been different. And certainly there's something out there, but we shouldn't necessarily, we only know what happens here and now. I think that's part of it. I don't think Wolf's saying the universe doesn't exist and didn't used to exist. I think when he said that everything that he sees is in his past, I think that's the main point.
Well, there's clearly a difference between, here we're talking about basic electromagnetic interactions, right?
Yeah.
Sooner or later. You see it with your eyes or you see it with a detector or something.
Yeah.
There's clearly a difference, poorly discussed in the textbook physics,
Not even
between the
yeah.
time of emission and the time of reception.
Right.
Same time.
And that confusion leads to all of this crap about
Exactly.
special magic and,
Squeeze space and so
and
on.
relativity and all. If you talk about the time of emission and separate that out, don't put that in your Lorentz transformations, along with the time of reception in other parts of your transformation, then you won't come up with magical,
You don't need
mystical.
You don't need it. Relativity puts them at the same point in space-time, photons. So
Well,
that stargazing is right here, right now.
Exactly.
As Wolf says.
It's,
No, but you're describing not the physical world that created those sensations, you're describing the phenomena connected with seeing them now as an existing being.
I think as a true physicist, though, we have to accept the experiment. And the truth of the matter is that light doesn't get emitted if it can't also be absorbed.
Right.
This is the one that's
If
that is true, and I
that's a
believe
paradigm. That's a paradigm
it
that
is.
not everybody agrees with.
I agree. In fact,
I don't agree. I don't think anything is being emitted. And nothing is being absorbed. The two charges are in an interaction,
Yeah.
according to Gauss's law.
Yeah.
There's no switch on Gauss's law. You don't turn it on, turn it off.
No.
Look,
It was created that way.
we
All the
have-
charges in the universe were tied together in the beginning, and they stay that way. And they're talking to each other through this Gaussian
Everyone's
R squared
involved in
type.
the discussion this evening over a beer. Of course, that's
Huh?
a good one.
Let me just read something. I picked this up just a little while ago. Okay. The traditional dualism of mind and matter,
Yeah.
which I regard as mistaken, is intimately connected with confusions. So long as we adhere to the conventional notions of mind and matter, we are condemned to a view of perception that is miraculous. We suppose that physical processes starts from a visible object, travels to the eye, there changes into another physical process, causes yet another physical process in the optic nerve, finally produces some effect in the brain, simultaneously with which we see the object from which the process started, and seeing being something mental, totally different from a character from the physical process which preceded and accompanied it. This view is so queer that metaphysicians have invented all sorts of theories designed to substitute something less incredible. But nobody notices an elementary confusion. Bertrand Russell.
I always like asking the question, which is a sort of a calibration question. Do you see the same way that I see? Nobody can answer that.
No, the answer is you don't. There's no way, even in the classical world, the photon splits.
No, I'm not talking about the photons. I'm talking about you, that you there. To me, it's
You then project you project the explanation into your model, and because you and I have the same heritage, in other words, the same basic structure, we can, through a lot of communication that happens when we're 1 and 2 years old, come up with a very coordinated set of words and other words that make all this happen. If you were a bat, as they say, what's a bat? I'm sure they see the world very differently.
Well, that's from the sensitivity point of view of the eye. But what I mean is, what I see that color as blue there. With the color that, if you have to put that color down, I might see it differently or whatever.
In Polish, there are 2 words for blue, and blue encompasses green at one end and blue at another. So people see things differently in the way they describe them as well. But every individual process and the way you paint your world is quantum interactions, which are utterly personal, from to bang, absolutely. And those multiplicity of interactions paint your world. So my world is completely, not completely different, because we, in a room close to one another, we're both human, but ours is individual in that sense, but not in that.
Can I ask?
And some interesting things is what happens when this coordination fails. Well, some of us get thrown into the booby hatch, right? And some of us, there's all kinds of sparks that start to fly because, as we know, especially in the United States, there are at least 2 worlds out there that we're living in.
For the time being.
Can I ask a quick question?
Yeah.
So since it seems like you've symbiotically placed the observer and the observed in their quote-unquote proper positions, so I'm wondering, is it the interaction, that action you were talking about, that action integral, because the observer is now kind of symbiotically interacting with the observed world, is that sort of, when it comes to quantum, is it sort of the source of, in this sort of cognitive action theory, the source of indeterminism in measurements? Or, I mean, is it, am I?
Yeah, very much so. I mean, you know, you can explain almost everything and all these mysteries in quantum mechanics through this. You know, one I've done is, you know, kind of explain this collapse of the wave function with this last slide. But the many things like this Heisenberg uncertainty principle is easily explained because when you have three things, you know, the system, you, the observer, and the rest of the universe, you never know what the rest of the universe and the system is doing. The rest of the universe is basically the clock in classical mechanics, and it's always interacting, because even in classical mechanics, if the clock goes forward, then the system is moving forward. It's always interacting, and you, the observer, will never be able to know unless they tell you. Right? Which means that even if you reduce them everything down to the minimum, meaning the quantum of action, of interaction, there's always that little bit of uncertainty that maybe the clock has now just interacted with it. So it's very easy to explain uncertainty and the whole statistical thing of quantum mechanics by simply a lack of knowledge. Now, people are going to say, oh, well, aspect experiments and so on. Now, they looked at that real closely, and there are some basic flaws in those experiments. And we have to look at all that very carefully.
I like your holistic approach where you include.
Yeah, no, I mean, I think it's the next phase, and I think, you know, the other, you know, the talks we just heard, the squeeze light and so on, really fit into this very well. In other words, we're no longer talking about point particles. That's a big problem. You know, what are the high energy people? Their particles are all points. But they're not. So there's always this interacting, squeezing and stuff, and you know, there's just this long list of stuff that always boil down to one assumption. And the one assumption we have to give up and develop is, no, we are not interpreting the world as it is. We are interpreting the world that has been processed into our display system. And there is always an interaction between the display system that we may be projecting into that outside world and may not be projecting. So what we do, what physicists have done, and you guys know this, is interpret stuff.
Yeah.
And included is always the prejudices of the self. And we need to separate that, recognize that what's out there and what we see are, and how we explain it are two different sensations. One comes from the outside, one comes from the inside our memory models. The two merge, and we see both of them together. When I look at you, and even my words, I always think, you know, I'm seeing a chair. No, I'm seeing black stuff, and I'm seeing some colors, and I'm seeing this stuff. It's interpreted into something that then I say, oh, it's a chair. Our language doesn't allow us to even explain the mechanism inside that changes the colors, the blobs, the objects, into the assumption that there's an object. It just says there is. And it's that assumption we need to break, and we need to develop a new physics without that assumption, and that's where the progress is going to be made. And I think much of what I've heard you guys talk about.
But I think you've also given the proof that actually can't be done, just for the reason that you can only interpret the world, and that's it. And that's just what we have to live with. So
that's what we have to live with.
Yeah.
But this
and you're right. But it's not going to give us any better physical theories.
Well,
but that's
I would argue with that one, but I think
Plato's analogy is a movie on the walls of a cave. It's only when you detach and turn around that you have any hope of figuring this out. And that's not anything that we see out here has anything to do with reality from some point.
Well, it obviously does, but the question is which is the right one, and I think we're simply stuck here. Which
is it a language issue then?
Is that no, this is what we see. The world always divides into the symbols and the thing, and then there's an interaction always between the symbols and the development of what you see on the outside. It's like there's an interaction in what I see and what I say, which is I'm talking symbols.
Well, we can take Plato's movie on the cave to go into the regular movie theater. We're immersed in this thing on the, but I'm claiming that that's not any more real. We have to totally detach from this to get it, understand what consciousness is.
Where are you when you're detached?
Anyway, we're over time. Please come back from lunch on time so we can keep the schedule.
You have your real, I have my real too.
I give it